we've already pretty much, bouncing around, have done just about all of this. Histograms, no. Searching an array, yeah, we have done that. Sorting an array, well, you can always just call arrays.sort. I could also make y'all implement the selection sort or the bubble sort, whatever those are. Those aren't really used out in the wild pretty much because there are more efficient sort algorithms. It's just that they are much more difficult to comprehend. So, textbooks and first or second year programming courses don't cover them. The way a selection sort works is, let's see if we can find an animation. Yeah, 29 seconds looks better than. All right, so what is it going to do? Did I start the recorder? Yes.
Oh, I've watched that video on the right so many times. Satisfying.
Oh, for Pete's sake.
The first one, the next one.
Yeah.
It's just so satisfying watching it sort through all.
Right. So, what does it do? I guess I should watch to make sure I know which way it's going to go. Okay, yeah, it's going. Okay, the way that I expect. It tucks in its brain, I need to find the very smallest value and stick it in position 0, or actually do a swap. So, right now, 35 is our smallest value, just like when we're searching an array, right? We are searching an array. Then it goes, is 97 the smallest? Nah, it's not less than 35. Is 19 the smallest? Nope. Is 4 the smallest? Yep. Now we have a new smallest. Is 57 smaller than 4? Nope. 27? Nope. 98? Nope. 36? Nope. So now it knows that 4 is the smallest value. And hopefully it kept track of the index position of that too. And so it swaps those. All right, now they're swapped. Now we never have to look at this one again. Go here. Do the same thing. It's going to find the smallest one, which happens to be a 19. And it's going to swap those. Right? And it's going to keep going like that, right? Now, starting at this point. And so obviously, as it gets closer and closer to the end, it's going faster and faster because it doesn't have to search through this stuff. And as far as easy primitive search algorithms go, and not search, sort algorithms go, this one is not half bad. The worst case scenario is if it's an absolute sorted order or reverse sorted. I forget which. Forget it. All of these search routines, the simple ones that do the passing like that with the looping pass like that, all have a set of data that is the worst possible case. Like bubble sort is a different one where it pushes the largest number up to the top, swapping each time. And then by the time it's done all those swaps, the largest number's here, and then it passes through it again, swapping all the numbers in order until it gets to that one. Then it does it again, swapping all the numbers until it gets to that one. So these three are sorted, and it keeps swapping. They're kind of bubbling up to the top. And that one's performance is at its absolute worst if you give it data that is sorted in inverse order to begin with. Because then it has to sort it has to do a swap every time. And that swap does take a finite amount of time, right? So algorithmically, if you're measuring the amount of time or the amount of cycles required to do that, the bubble sort is really bad at handling it when the data is in inverse order. Selection sort has better performance in the cases of the worst possible cases. So even if on average it may be a little bit better, and it's used in certain cases even in the more complex sorting algorithms as part of what they do. Now, like Vincent said. We could turn the sound off. All right, let's rewind it and see the name of the sort. This is the selection sort in action. You see what it's doing. It's finding the smallest one and putting it in the next possible position. And then there's the insertion sort, which I don't even remember how it works, so I can't explain it. Clearly it's doing some kind of swapping and stuff rather than just pushing everything to the end, the beginning, I think.
Does it just take all the numbers and puts it in its own separate array and sorts that by order?
Yeah, a lot of them do create a second array, and and the really efficient ones, the ones that are speed demons, use recursion in order to do it, which is a different concept. There we go. That's cool. That's quicksort. This is one of the ones that's more difficult to wrap your brain around. But check out what it's doing. Whoops. Come back to quicksort. Come on. I'm still not able to understand what it did. But it broke it into a half, right? This half and then this half. And you know that this half, nothing in it is smaller, right, than the minimum value of this side. And nothing in this side is larger than the maximum value of that side. So these two blocks, it's like, you're trying to sort your Legos. And so you just said, okay, I'm going to put all the red ones over here and all the green ones here. And then, okay, now I'm going to split my green Legos up by, the number of studs on them, right? And then I'm going to split those up by, whether they're 1 or 2 or 4, whatever, And so that's what it keeps doing. It keeps breaking it down so that they're partially sorted, half and then smaller and smaller and smaller. And then when that portion of it's done, it goes back and it picks another part. This is fun. Thank you for encouraging me to show this.
The sound makes it
Merge sort. Neat. This is cool. I love it. We're going to sit here and watch all 10 minutes. No, I'm kidding. There we go. Onward and upward. I'm not going to make y'all look at the source code for selection sort. I think one of the projects that I'm going to offer is to compare sorts. I know I did that for, for the Java 1 students, and nobody did it, so there's no reason not to offer it for y'all.
I did the last one, right? The fighter one?
Pardon me?
I did the fighter one, the last one on the...
Right, right.
I did the first one. Easy one. Oh, changing the array.
Was it the Caesar cipher things?
It was the Caesar cipher.
Yeah.
Yeah. So when you create an array, if it is not just a simple array of numbers, right? If you make an array of numbers like this, it goes ahead and we now have A is now a reference to 5 consecutive places. Come on. Places in memory that can hold an int. I'm going to call that A1. What if it's an array of objects? Right? We declare an array of circles. So somewhere we have a class called circle, and blah, 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 blah. Who knows what's in it? Then we make an array out of those, right? So circle, but it's an array, A2 is equal to new circle, and we want Circe, Greek goddess or something like that. There we go. There. Now A2 is a reference to 5 consecutive places in memory that can hold references to circles. So we don't really have any circles. We just have, you know, a box that can hold 5 circles. You know, we have 5 mailboxes ready to hold, each one ready to hold a circle. Once we have that, we can start sticking circles in it, right? A2 subscript 0 is equal to new circle, right? Now he's got a circle. A2 subscript 1 has got a circle. A subscript 2 and 3 and 4, the other 3 all just have null at this point because it's all initialized to null. All of these ints are zeros. All 5 of those places in memory are zeros. At this point, all those references to circles, if you don't create a circle, we have nulls. A null is just a fancy word for a 0 when you're talking about memory addresses. When you create an array, before you put any data in it, or unless you use an initializer list, all the values default to being some form of 0. And that's different than the C or C++ language, where if you create an array of ints or whatever, you have no idea what numbers it's putting in there. It's just random garbage until you actually initialize it. But in Java, it's all zeros or it's all falses, right? If it's an array of Boolean or if it's an array of floats and doubles, it's 0.0. I don't know what it is if it's an array of characters. Probably all, again, zeros, but whatever the 0th character in the ASCII chart is. Like that. For some reason, whenever on an exam I ask what the default value of all the elements in an array are, everybody gets that one and that one and that one, and then they decide that the Boolean default value is going to be true. And no, 0 is false, 1 is true. Just see if you can remember that. And so it's going to be 0. You can always check the length of an array with .length, which you poor C++ programmers weren't able to use. We've talked about partially filled arrays. That's when you have to keep track of how many elements are in the array, because some of them are valid, some of them are not. Here we go. We have 2 valid circles and the rest of them are not. So we should have a counter of some sort, like, you know, numcirc or something like that is equal to 2. So that we know that our loop that's going to print out all the circles would go from 0, you know, whatever, for I standing for index value is equal to 0, I is less than numcirc, right? And that way it's going to only print out 0 and 1. So that's a partially filled array, and once we fill it to the max, it's no longer a partially filled array. Some arrays will never be partially filled arrays, right? But sometimes they will be, and if that's the case, you have to do that. Now, another way to handle it would just be to have a loop like this. I is equal to 0, I is less than the array.length, I plus plus, and you could just check. If that array element is not equal to null, then it's pointing to a circle, right? And you could do something with the circle. Like that, right? That's a valid way of handling it, rather than keeping track of that. But that really only works with references, right? If it was an array of ints, you know, 0 is a valid test score, or 0 is a valid rainfall amount, or a valid, you know, so you couldn't just use it like that. And sometimes people will concoct some, you know, if it's got a temperature of -999, then that means that hasn't been assigned yet, right? Because that's an impossible temperature, hopefully. Right, right. We've talked about copying an array. Histograms. A histogram is when you're trying to calculate different values. Remember when I was talking about Legos? You might set up a histogram for Legos And let's declare it as an array of ints. And we have decided that our Legos have these possible colors. And so if you have color is equal to 0, that means it's blue. Color is equal to 1 means that it's a green Lego. Color is equal to 2, that means it's a red Lego. Red, green. All right, there we go. And then you can just go through. Well, firstly, you have to decide how many Legos you have, right? New, int, let's say we have 100 Lego pieces. And now our loop's going to look something like this. Pick up a Lego, look at its color. If it's blue, then hist underscore Lego blue plus plus. Add 1 to that value. Now I should have changed this a little bit. Blue is equal to 0, green is equal to 1, and then red is equal to 2. And so if it's blue, then histogram of Lego blues like that. If it's a green piece, then the array for element 1, I hope I'm giving a good example of this because I'm sure I'm doing a lot of typing. Hist Lego subscript green gets increased by 1. And then if it's red, then histogram underscore Lego red gets increased by 1. So here's what our array looks like right now. We have an array with 3 spots for ints, right? It's got a spot there, it's got a spot there, it's got a spot there. When it starts off, every spot is 0 because that's what happens when you allocate an array. Everything gets set to 0. We have decided that this spot, index 0, represents the number of blue Legos, and that this spot here represents the number of green Legos, and that this spot here equals the number of red Legos. And then we go through, okay, pick up a Lego. Is it blue? Nah. Is it green? Nah. Is it red? It sure is. So set Lego subscript 2, add 1 to it, right? Now do the same thing. We grab another Lego. Is it blue? Yeah, sure is. So add 1 to Lego subscript 0. Now go through again. Pick up another Lego. Is it blue? No, it's not. Is it green? No, it's red. Okay, we have another one. So histogram Lego at index 2 gets added. So this was our blue one. This was our green counter. And this is our red counter at index values 0, 1, and 2. And so when it's finally done, you can just do something like this. Print, blue, and then blue count is equal to, and then histogram underscore Lego at blue. Right? And then do the same thing for green and red. This actually wouldn't be a bad assignment to give you, although maybe generate random numbers or something like that. Never given a histogram assignment before. I will be mulling that over in the back of my mind whether I want to do that or not. All right, so there we go. Right? When we printed it out, the first line of the output would say blue is equal to, and then it would check our array. And what's the index value for blue? It's 0, so it would print out a 1. And then we would hit it again. We want to print out the number of greens, and so what's the index value for green? 1. So it would print out a 0. And then we go over here, what's the index value for red? Somebody say it. 2. Right. So it's going to find this second element number 3. Well, index value 2 in that array. And so it would print out blue equals 1, green equals 0, and then, number of reds is 2. How about we put number signs in front of them? Right, like that. So that's the idea of a histogram. Yeah, we could draw a graph if we wanted to. How would we draw a graph? With a for loop. It would be a nested for loop, which is worth talking about, right? Because if this guy here's how we would do it conceptually. I'm not going to write the loop yet. But we would want the first element. And then we would loop printing a number of asterisks. All right, that guy had 1 asterisk. It was easy. Then we would go and look at this number. And we would write a loop that would print out the number of asterisks. Nope, there's nothing to do there. And so we would go to the next one. We would pull that number, and then we would have a little sub loop that would print out those number of asterisks, right? Like that. And so, you know, blues like that, greens like that, make them line up. And then reds are like that, right? Something like that. So you can print out a histogram graph by using a nested loop. Well, what's that loop going to look like? Well, we only have 3 different colors, right? 0, 1, and 2. So here's what we could do. For, you know, color is equal to 0. Color is less than or equal to what's our highest value. Our highest index color is red. Color plus plus. I wish I'd chosen a different name than hist_Lego. Maybe I'll do a search replace and just call it hist. Let me guess, I messed us all up. Yeah, that was a bad idea. Okay, so that will check first this value, and then this value. You know, we could extract that, right? Number of items. Number of items is equal to the histogram at that position, right? At first, color equals 0, so it's going to pull out a 1. So then we have a smaller loop. I don't know why all of a sudden I got picky and started doing, you know, int when I hadn't been before. And then I is less than num, I plus plus. We're going to actually have to code this. This is fun enough to actually do it. And then print a star. And after it's done printing all those stars, we're going to print, you know, print line like that. So it would find the 1, it would loop, printing out asterisks until it was done, and then it would print a line. And then it would come back through here, color would equal 1. Well, since we only have 0, not going to print anything. And then it's going to print the carriage return. And then we come up here and we hit the third one. It's time to print it out. So num is equal to 2. And then we're going to count I is equal to 0 and then 1, printing out asterisks each time. I think that's worth doing. We did not do this last time, did we? We did not print a graph based on a... Did we?
No.
All right, all right. Are we in lecture G? That seems unlikely, considering how... Pardon?
That's what I put.
Okay. And here it's wanting us to talk about arrays of objects, but we may not be doing that. We've already kind of broached the topic. All right, so file new. I'm going to call my project lecture G. How's that? All right, I remember how it's possible. All righty, so same example. You know, we're going to change eventually this 0, 1, and 2 to be an enum, an enumeration, which is just a sequence of numbers that have names. But for now, int red is equal to 0, comma, green is equal to 1, comma, blue is equal to 2, semicolon. Let's make a parallel name. Let's make an array full of names, right, so that we could print them out with a pretty name. So I'm going to make an array called colors. And I'm just going to pre-fill it. You know, I'm going to initialize it to quote red, quote, comma, quote green, quote, and so on. So string is square braces, should be a capital S, pardon me, colors equals red, end quote, comma, green, end quote, comma, blue, end quote, comma. And now let's actually make our histogram of Legos. Just going to call it Legos. You know, that's actually not correct term. We're supposed to just say, use the word Lego even for plural. That's the way the Danish want us to do it. We don't have to follow their rules. All right, so anyways, here we go. Legos. And it needs to be 3 elements long. So I'm just going to initialize it to the length of this array. Equals new int subscript, and inside the subscript I'm going to do colors dot length. Why? Because these are parallel arrays, right? We're going to have a count of red, we're going to have a count of green, we're going to have a count of blue. I see how we could turn this into being an array of objects. We'll work on that next. Alrighty, now let's just stick some data in there. Legos subscript red in subscript is equal to 5. I'm just assigning a random value. We've, magically fill the array. And then the Legos, the number of green Legos we have is 10. And then Legos subscript blue in subscript is equal to 3. Now we're going to use a nested loop to print it out. The outer loop is going to step through our array. It's going to find the 5 and the 10 and the 3, and the inner loop is going to print out asterisks, representing the length, of the bar that it's drawing. Now, if you want to flip it so that it draws it from the bottom up, that's an entirely different challenge. And when I say that, I don't even know how I would do it. I'd have to give it some thought. All right, so print the array. Let's use a for loop. This is going to be which color we're on. So I'm going to use a counter called, an index counter just called color. And it's going to go 0, 1, and 2. So for int color is equal to red. We're starting at 0. This is making it awfully dependent upon, the order of these things. Semicolon. And keep going while color is less than or equal to blue. Certainly is going to mess this up if we start adding colors or change the sort, but let's just roll with it. And then color plus plus. What are we going to do first? We're going to print out what color we're working on. And it'd be to our advantage to space it out correctly. So I'm going to use a formatted print. I'm going to use a printf. So it's going to be system.out.printf. System.out.printf. Parentheses, quote. What's our largest color? Green? And let's make it like 10 characters wide. What if somebody throws in chartreuse or something like that? I'm not sure how long it is, but anyways. So %10s. Percent meaning this is a placeholder, S meaning that we're going to fill it with a string, and 10 means reserve 10 spaces for it, pad it out to 10 spaces. And then maybe a couple spaces after that, because then we're going to put some asterisks. So one space after that. Comma, the name of the color, which is going to be colors, subscript. I kind of wish I'd just called it I rather than color. I've decided to change that. I'm changing those words color there to I. And I'm going to put I there. Now we need an inner loop to print out asterisks. We've already used I. I think I'm going to just use X. I don't like using I and J. They look too close apart, too close together. So int X is equal to 0. X is less than the number of elements at that position. Legos subscript I. In subscript, semicolon, and then X plus plus. Now let's just print It could just be a regular print. Better not do print line. We don't want to go to the next line until we print out all of our asterisks. Like that. And then once that loop is done, and yes, I could have used curly braces, we're going to print a new line. System.out.println. Go to the next line once we've printed out an entire row of asterisks. It's possible that this is actually good code and is going to work. It's also possible that I filled it with either logic errors or syntax errors. Trying to get it all on the screen. Probably a fool's errand. Okay. I can if I put the comment out here instead. Print the array as a bar graph. All right. I'm eager to see if that works. Yeah. It even kind of justified, right justified these strings. If you don't like the strings being right justified, if you want them left justified pushed against that border, then you can put a minus sign after the %, and that left justifies it. I think it's kind of cool right justified myself, but there we go, right? Whichever one you want. So, that's how to present a bar graph based on a histogram. So a histogram is just an array where each element in the array is a counter that represents, a discrete quantity of a certain item, right? You could have, a histogram of, how old people are, right? Age group. 17 and under goes in the first spot, 18 to 65 goes in the second spot, and then greater than 75 goes in the third spot. Or income categories, right? People who are earning less than $5,000 go in the first one. 5 to 15 go in the second one. 15 to 25 go in the third one. Whatever your category means. That makes sense, gang? Anybody need eyeballs on their screen? If you ever get stuck, do a clean and rebuild and see if that magically fixes the error. Kind of like turning a printer off and back on. If you do tech support, you always tell the person, make sure that it's plugged in. They'll always tell you it's plugged in, so you then say, unplug it and plug it back in. And then they go, oh, it wasn't plugged in. All right. I want to write one more nested loop just for giggles. What if we wanted to print something that looked, don't type this. What if we wanted to print, do it in Notepad. What if we wanted our output to look like this? 1, 2, 3, 4, 5, like that, right? 6. You'd use a nested loop. The outer loop would control what line we're on, and the second loop would count the number of asterisks on that line. Now, I'm not going to use arrays or anything to do that. So let's write two versions of this. Let's write one that'll print out a block. That's kind of an ordinary nested loop problem. And then let's print one out that prints that triangle. I may have even asked you all to do that in the past, in the first class. But not everybody had me for that class. Okay, so I need a number of rows and a number of columns in order to accomplish that. Int rows equals 4, comma, cols equals 5. Now we're going to use nested loops. And don't let it bug you, but I'm going to skip using curly braces entirely. You don't need to do that. For int x equals 0, semicolon, x less than rows, semicolon, x plus plus. That's the outer loop that's counting the number of rows. And tell you what, why don't we make that r instead of x, because it's the row counter. The inner loop, the nested loop, same business, except it's going to be c is 0, c is less than cols c plus plus. For int c is equal to 0, c less than cols, c plus plus. I do need curly braces. I was rash in ignoring them. Sorry about that. Put a curly brace there, put a curly brace there. Now we're going to print out our asterisk. I am lazy and I'm just going to copy that print statement. If you can type it faster than you can copy and paste, great. On this inner loop, I could have gotten away without using the curly braces, just like we did up here. And then after you've completed an entire row, then we print out a blank line, which is going to be another system.out.print line. I'm going to copy that, paste it there. All right, now that'll print out a rectangle with 4 rows and 5 columns. Why are we doing nested loops when you've done them before? Because that's how you access two-dimensional arrays. So we're doing another example of it. Maybe we'll... To do the triangle, we're going to make it really, 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 really easy. All right, and there we go. 4 rows of 5 columns. Now to do the triangle that I mentioned, just copy all that, but instead of rows, just put a number, like 4. Yeah, I'll show you. I'll show you. I'm not going to just tell you in advance and make you do it. 4 parentheses, int r is equal to 0, r is less than 5, r plus plus. This is going to be a triangle of 5 rows. And tell you what, I could actually, use that variable there, but I'm going to leave that alone. And then inside it, 4 parentheses, int c for column equals 0. C is less than r, not 5. I typed 5 while saying r. C plus plus. Then print out an asterisk, just like this. Print that asterisk out, and then print out a blank line underneath it, like that. I'm going to make this number large. I want like 15 rows in my triangle. And there we go. Right? We printed out our little box, and then we printed out a triangle. So we have several different examples of nested loops at this point. We have the one that's printing out the histogram. We have the one that's just printing out a rectangle. And we have one that's printing out, a triangle. And the reason a triangle works is because we base our second loop on r from the first loop, right? So when r is equal to 1, it prints 1. And then it flips back around again, and now r is equal to 2, and so the inner loop goes, 1, 2. And then r is equal to 3, and it goes 1, 2, 3. And r is equal to 4, and it goes, the inner loop goes 1, 2, 3, 4. Like that. Although it's really going to 0 to 3, but you know what I mean. All right. Who would like a pair of eyeballs?
No, but I think I just found it.
Yeah, take take that parentheses out and the one after the 0. Two-dimensional arrays. As I said, we were going to do arrays of objects. We've already kind of talked about arrays of objects, but we could do the Legos as an array of objects. Show of hands. Two-dimensional arrays. Another show of hands. Objects. Back to two-dimensional arrays. I know y'all don't care. All right, now we have one vote for one. Objects. No votes for the other one. I don't give a hoot. Wave both hands. Yay! All right. Okay. There, we have a decision. Let's do a two-dimensional array. A two-dimensional array is just an array of arrays. Remember when I was up here talking about, when you declare an array like this, what it is it's a reference to 5 consecutive places in memory that can hold an int. And then you have an array of classes, objects, and so it's a reference to 5 consecutive places in memory that can hold a reference to a circle. It's a reference to a reference. All right. So what if you had an array that looked like this? It had 5 spots. And the first spot was a reference to this array. Let me do that, right? The second spot was a reference to this array. That sounds like disarray. I guess my thinking is in disarray while I'm talking about this array. All right. And then the third one was a reference to that. That's enough, really, right? So this element here, just going to stick an A in it to kind of distinguish it, right? Array, element 1. And then this element here is a reference to the second one. And this element here is a reference to that one. Now instead, let's pretend that these are numbers, right? That's index value 0, that's index value 1, and that's index value 2. And just know that they line up, right? I don't know how to put values in there that make you think that they go to there. Just know that that's a memory address that's filled with that one. Maybe I'll do that. I'll add it as a comment. So it's an array of arrays, or it's an array of array references. That's a two-dimensional array. Now normally you don't think of a two-dimensional array as being an array of array references. Here's what you usually think of it as being. 2D array representation. Let's look one up. I sure hope that I can find one that, right, like that. That's how we think of a two-dimensional array. It's something that's got columns and it's got rows. Now forget the fact that it's got days up there and it's got routes there. That's just using parallel arrays so that we can give these categories names. But you see what it is? It's just like when you're playing Battleship, C5, you sunk my battleship, right? Instead of using letters and numbers, we're using letters for both. So this position right here, 0, 0, you would call, whatever the name of this array is, you would call that one, array 0, comma, 0. I hope it's not that, because my brain just blipped. I was teaching a language in which it's one and then in which it's the other. So, dimension. It is. What do you know? Okay. All right. That actually makes sense, though. So, array element 0, 0, row 0, column 0 is equal to an 8 in this case. And an array element 1, 3 is what? Row 1, blip, blip, column 3, 0, 1, 2, 3, that's a 0. What are the row and column values? You probably can't see this. Let me zoom in on it. Give me the rows and column values for the value that's equal to 15. What's its row?
2.
Yeah, it's in row 2 and it's in column what?
1.
Okay, so going back here, array 2 subscript 1 was equal to 15. That's how you index the array. What is really going on when you do that? I'm going to make this one match that one. It's going to be 8, comma 0, comma 0, comma 0. And then 1, comma 3, so it's going to be 0, comma 0, comma 0, comma 3. And then row 2, 0, comma 15, comma 0, comma 0. And that actually wasn't a 3, was it? It was a 0 right there. Of course, I don't have to make it the same as that picture, but you get the idea. So this is our array. The array was allocated something like this. Int, but I would remove all the spaces, those are superfluous. AR is equal to new int, and it's a 3 by 4 array, like that. And that created an array that was 3 elements long, and each one of those elements was a reference to an array that was 4 elements long. So when we say I want array 2, 1, what is it doing? It's really AR element 2 gets us the array, right? And then AR element 2, element 1 gets us the position in that array. All right, at this point, I'm going to stop calling it an array of arrays. I want you to just have that tucked away in your head, because when you go into program in other languages, it'll be the same thing. Excuse me, yeah. Instead, we're just going to call it a two-dimensional array, which is a grid or a matrix. All right, no more talking about arrays of arrays. Let's create a two-dimensional array in our code. So int, since it's a two-dimensional array, we have to have 2 square braces. And I'm going to call this 2D. I wish I could call it the number 2D, but you can't create a variable name that begins with a digit. Is equal to new int, and I want this to be a 3 by 4 array. And I did it wrong. I keep going to the C nomenclature. Subscript 3, subscript 4 in subscript. That would create an array of 3 rows and 4 columns. Now the syntax for creating an array, a two-dimensional array, and using an initializer list is pretty hinky, pretty weird. Int subscript, int square brace, and I don't even know what to call this one. How about init? Inits, I don't know. AR. AR array 2D, I don't care, is equal to, AR2D equals, I'm changing that to R2D2 because I feel like it. Right, okay. Int subscript R2D2 is equal to, now curly brace there, hit the next line, and then make another curly brace, and let's just type in some numbers, doesn't matter what numbers they are, right, like that. And then a closed curly brace followed by a comma, and then repeat that process 2 more times. Open curly brace, don't type my numbers, just, type in 4 random numbers off the top of your head, and then close it with a closed curly brace, and then put a comma. And then lastly, let's add 4 more numbers. But this time no comma, because it's the last element. But we do need a semicolon at the end here, because it's just like, any other array declaration ends in a semicolon. Now the syntax looks pretty goofy, and although I just promised not to say that it's an array of arrays, you can tell it's an array of arrays. Because this array is the first element of R2D2. This array is the second element of R2D2. And this array is the third element of R2D2. So what is the row, column, or the XY or whatever position of that 0? So it's in row 2, because that's row 0, that's row 1, that's row 2, and what column is it in? I think I heard you say it. Also happens to be column 2, 0, 1, and 2. I didn't mean for that to be the case, but whatever. So R2, D2, subscript 2 in subscript 2 in subscript is equal to 99. At that point, our array has changed in memory so that there's a 99 there, which we will see when we print it out. And we need a row and a column counter, int r is equal to 0, r is less than the number of rows. Well, how do I pick out the number of rows? Dang, good question. I think it's just r2 d2 dot length, semicolon, r plus plus. And in curly brace, the inner loop is going to be C, so for parentheses int C is equal to 0, semicolon C is less than what? It's equal to the number of columns. Now it's possible that up here I would have dictated that this was a, that the number of rows is equal to this and that the number of columns is equal to this, but I'm showing you a flexible way of doing it to where it's based on the properties of the array itself, right? So it didn't matter how large this array was. We would not have to change this code. But we do need to know the length of that particular row. So R2, D2, subscript R in subscript, dot length, semicolon, C++. Curly brace. Same business. We're going to have a print there, and then we're going to have a print line here. So here, system.out.print f parentheses. What's our format string going to be? What's the largest number here? How many digits long is it? It's just too long. So why don't we give ourselves 3 spaces for each number? Percent 3D. D is an integer. F is a floating point. I always wish D was double, but it ain't. Comma, the value at that position, R2D2 subscript R subscript C. R2D2 subscript R in subscript C in subscript, end parentheses, semicolon. And then system.out.println. And I can already tell what I'm going to have y'all do. How many rows would you like your array to be? How many columns would you like your array to be? Fill this array with random numbers, right? That kind of thing. Print it out. Let's see if it works. I want to see if I get this data, but with the 0 replaced by 99. And why did I make it %3D? Because if I hadn't done that, if I just made it %D, or just use a print statement, it wouldn't look so hot. Show you what I mean. Right. Okay, that's pretty cheesy. Even if I had embedded a space here. Yeah, still lousy looking. What if I put my thinking cap on and I stick tabs there? Much better. I could have gone with tabs rather than %. But why not just specify the width? What if my numbers can get up to 999? I'm going to give myself 4 spaces now. All right, so %4D. And there we go. You want the numbers left justified rather than right? What symbol did I say you put after the % sign?
Minus.
Yep, a hyphen, a minus goes right there, and that will left justify every number in it. If you think that's prettier, I kind of think it is. It's up to you. All right, we didn't actually use this array right here. But it shows us how to allocate it, right? 3 is the number of rows, 4 is the number of columns. And then the rest of this was for printing out, declaring this array. If I ask you to create an array of a certain width and a certain, number of columns, don't do it like this. That'd be crazy. You only use this to initialize an array while you create it. And how many times are you going to know that data in advance? Probably not very often. Usually it's going to be some process that fills your array up. So that's the one to remember, actually. I just did it like this because I wanted you to see, row, column format. Row 0, column 0, column 1, column 2, column 3. And we always use those last 5 minutes in creating drop boxes and stuff like that. That Lego problem. Class. Hist element. So I'm just going to call it hist E. We're going to have a string called color. And I keep forgetting, in this language, string is capitalized. String space color. And then int space count. You can already see where this is going. And realistically, I should have declared this class in its own file, or I should have declared it outside of the other class. Instead, I'm sticking it right here. But later on, I'd cut it and move it up, right? This should make your teeth grit to see me declaring a class inside of a class. Okay, so let's create an array of hist references. Hist E subscript in subscript. What am I going to call it? Histogram. Histogram equals new hist E subscript, and we just want 3, RGB. Now we have an array that's got 3 elements which can hold references to hist objects. So, hist E subscript 0 in subscript is equal to new hist E parentheses in parentheses, and then set quite liking where this is going. Hist E subscript 0 in subscript dot. I'm not liking that. Delete that. Let's do hist E space T for temporary hist equals new. In fact, hist E space T. We just need a reference to point to histograms as we create them. And then T equals new hist E, I should have just called it hist, huh? Parentheses in parentheses, and then T dot color equals, quote, red, end quote, semicolon, and then T dot count equals 3. We have 3 red Legos. And now we have to stick that into our array. So hist E subscript 0 is equal to T. Now I'm going to copy and paste that code 2 more lines. Whoopsie, it was actually called histogram. I'm so sorry. This line should be histogram subscript 0 equals T, semicolon. All right, so we created an object. And I'm trying to write this in the best way possible, and so I'm sorry I keep tweaking it. Call this one T. Make it this line, hist E space T. Make it say hist E. I'm getting really tired of typing hist E. I really wish I'd just chosen a hist. T1, comma, T2, comma, T3. And then make the next line say T1 equals new hist. T1.color equals red. T1.count is equal to 3. And then copy that line and make T2 something else and T3 equal to something else. T2, T3. Here's where a constructor would have been a good idea, right? But this one is not red, it's green, and we have more green Legos than we had red ones. And then we have blue Legos, and we have 5 blue Legos. And so histogram subscript 0 is equal to T1. Histogram subscript 1 is equal to T2. Histogram subscript 2 is equal to T3. Now we could process it again with a nested for loop. But we're not going to be using a parallel array to drag the colors out. Instead, we're just going to query that specific element. And it's not a two-dimensional array, so we could use a for each loop to do it. I'm kind of feeling like doing that. We haven't used a for each loop today, and they are the best thing since sliced bread, so let's try it. Hope it's okay for me to tab this stuff down. So for parentheses, what's our class name? Hist. I really am tempted to do a search and replace, which is Control H, typing in something and then typing a replacement name for it, but I'm not going to do that. For hist e space, how about the word element? Colon, and what's our array called? Histogram. So for every object in the array, we're going to print out the name of it followed by the number of it. So we're going to use another formatted print statement. System.out.print f parentheses quote. The strings, maybe we'd make them 10 columns wide, so %10s, followed by the digits, 5 columns wide, %5d because they're ints. And then after the end quote, comma, we're going to print out elements dot color, comma, element dot count. Oh, and then a backslash in. We need some way to go to the next line. I guess I can just do system.out.println after that. But I could have put a backslash in there to do that as well. And that's going to print out our little histogram. It's not going to do as a bar graph, but you probably see how to do that. You just have a counter in here, an inner loop that would iterate, x from 0 up to the counter, printing a star each time. Dot, 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 dot. I bet I lost somebody on this one because I started editing it midstream. And there we go. Now we have our second histogram. But we did it as objects, right? Every element in the array is a pair. Fancy term for it is a tuple. Tuple. Where the pair matches a color to a count. We have way cooler ways of doing it than this, but we'll talk about those when we start talking about so-called dictionaries.
What was the fancy word?
Tuple, yeah, like a double, a triple,
T.
just T-U. Yep. A
T-U.
tuple means
B-L-E.
any collection. It could be a double, it could be a triple, it could be a quadruple. Yes, T-U-P-L-E.
Ah,
Yeah.
alrighty.
the class is over. I'm going to make up the homework assignment. How about that? So here's what it's going to do. Just like I said, ask the user for the number of rows. Ask the user for the number of columns. Create an array. Create a 2D array of that size. Fill the 2D array with random numbers using a nested loop. And then print the 2D array with a nested loop. Bonus points if you can make it print the sum of each row as it goes. Like, 12, 20, and then 5 would be 37. Then on the next line, write, a 1, a 4, and a 6, right, a 7 is an 11, etc., etc. That makes sense? I mean, maybe it doesn't make sense how to do it yet. Maybe you have to do more reading or looking back at our code examples or asking me for help. But does the assignment make sense? Okay. Hope so. Let's make a Dropbox so we can skedaddle. And good. Elaine got to see that part. Alrighty.